Thank you. Fabulous and inspiring talk. We'll have a chance to discuss more at our final panel session in a sec, but let me move us on quickly to our next talk, which will be by a remote speaker. I'm very pleased to welcome virtually Alison Lowndes to the conference from NVIDIA. Alison is a deep learning solutions architect there at the company that's building much of the ML revolution and is now in charge of space at NVIDIA. And she's going to, slightly disturbingly, given that it's a virtual talk, tell us about, give a talk entitled "Open the Pod Bay Doors, Hal." Over to you, Alison.
Thank you very much, everyone. Okay, knock knock. Can everybody hear me all right? I'm hoping. I can't see anybody, so I'm hoping that you can hear me.
We can hear you fine. Yep.
Brilliant, thanks, Chris. Okay, so I may be virtual, but actually my colleague Sean is in the audience with you. So he's my mortal being. I also have way too much to tell you and far too little time. So forgive me for flying through this, but there's a PDF document with links available. And also, tech guys, feel free to just focus solely on the slides, and then we can get the full visual. So for anyone who doesn't know us, yes, we do gaming, but we actually do a whole lot more. So RTX, or ray tracing, literally redefined computer graphics. So those triangles on our HQ buildings, Endeavour on the left, Voyager on the right. We'd have called Voyager Discovery, but then it would have been a really lame quote from Armageddon. We do love space, though, and I actually lead space. We all actually have a lot to thank gamers for, because it was their brutal demands for excellence that got society to where we are today. So first, we had to get the sword slicing through aliens precisely, but now we can compute and simultaneously visualize the fluid dynamics of the vortices created by the retro propulsion engines of house-sized Mars landers too. This is work with NASA and Fun3D. But I want to talk about this first because we are in the decade that will define the future of humanity. To quote our wonderful David Attenborough, Earth is a closed system, and you only need to go into space to understand what that means. The fire colour here is where we've already messed up as a species. So planetary stewardship, Earth observation, climate defence is now just as important as military defence. Both are actually driving the space race this time round. And we have the technology. I was saying this 2 years ago. You know, we're still just waiting for someone to deploy it. There's no time to go down the LLM rabbit hole today, but you can run them on Jetson, which is our credit card-sized GPUs that actually might already be on the far side. Now, this is not what Carolyn was talking about earlier, NASA and AFRL's fission power source. This is NVIDIA's embedded processor. So the module is on the right in this diagram and the dev kit bottom left, operating at about 10 to 15 watts, depending on what you want to do. But what we're talking about here with autonomy is offering trillions of mathematical operations per second. So that's what the TOPS mean at the intake. And we can go even lower precision than intake. But my job is dealing with exactly what Carolyn talked about, and Vandy, you know, that hesitancy and mistrust of new tech. But ESA STEC, I've worked with them for years. They're now developing a product with Jetson, with a Belgian company that they support. Obviously, ESA's mission is to support right across the Europe. But this Jetson has the CPU and the GPU on board. So it's definitely not 17 minutes, not even 17 microseconds to transfer data between them. If you need full functional safety, we can offer that too. Actually, in my early years at NVIDIA, we were testing Orin's predecessors operating in oil to keep them cool because they were going to operate in the remote South African Karoo bush where part of the SKA is. But we were doing this years ago too. So here we're combining multiple libraries, multiple technological capabilities, voice, animation, even our materials definition language, which gives adds the leather look to Jensen's jacket, while RTX, that ray tracing, brings everything to life in high fidelity, in real time, with full chatbot capability. We move fast, we have to. I'm sure you're all very aware of the pace of AI research, which actually instills a lot of the fear that's out there, but we're also deploying it. So we have to follow first principles in every order coming from all of the major governments. AI is just code. So you start simple and you add complexity, just like evolution, only much, much quicker. I'm not going to reel off a bunch of specs here because only one matters. 25 times the energy efficiency of the last generation chip. In fact, for the embedded Jetson, relevant to most space deployments, we're skipping right over the Hopper generation silicon, straight to Blackwell. And if you want to run HAL in space, this is basically where you start. But you can test today on Hopper. But remember, there is a huge ongoing effort to deliver state-of-the-art autonomous vehicles, or what we call AV. Go see Arcbotica's incredible latest capabilities. So roaming around on the lunar surface is child's play. When you consider the capabilities we have today, neural scene reconstruction, any sensor data being input, optical, LiDAR, SAR. FDL is tackling a SAR FM, a foundation model right now, more on that later. But it's already being tested by the big agencies because it's already capable of handling far more complexity than we'll ever face on the moon. And I can say ever because in another decade, who knows what we'll be capable of with AI. And we've been playing with Apollo data for at least a decade. This was years ago when we debunked the debunkers of the moon landing at our conference. At the SIGGRAPH conference later this month, again, look out for FVDB. The F is for fundamental, for large scale, what we call spatial intelligence. Basically, being neural means that it's differentiable, which is actually two-way. So you can also recover geometry and meshes from images. Combine that with things like lighting data, and you can now do incredible things in world. And couple that with the incredible efficiency. So Hopper generation GPUs brought FP8, so precision here, which basically halves the carbon footprint, the compute required of most AI, especially large language models. Blackwell halves it again. So the broader the industry adoption, the better it is for the planet. And the more folks start using the metaverse, the better for the planet too. Almost 20 years ago now, my sustainable development charity put its office in Second Life. But there's actually hundreds of virtual worlds out there today. So we built Omniverse to connect them all, even for fusion reactors. So this is work with the UK's Atomic Energy Authority and the University of my hometown, Manchester, where we're tracking and predicting Monte Carlo neutronics. I show you this so you realise that we're not just doing gaming. Here are work by our team in Zurich, again using Omniverse to test buoyancy aids on landers. How? You just attach a buoyancy script to the prim. And there's lots more on our Omniverse showroom online using our Warp Ocean tools and all of PhysX's magic. But something called domain randomization. This is very, very important for what we call sim to real. So bridging the gap between the in-world, the virtual world and the real world. But generating synthetic data in-world is, again, child's play. Think spawning new characters in games. This is modern-day data augmentation. And with NERF, you have, bear with me 1 second, are you still seeing this? Because my screen is about to freeze. I might have to end and just reset in a second. Basically, with NERF, you have that capability. You can pull it into... my screen is freezing. Can you actually see that? Okay, yeah. So basically, you can pull in all kinds of AI. So lighting, you can generate with Gen AI possible, any possible object behavior. But it's all synced to the real world. Now, NERF, of course, depends on light paths. Zoom is taking control here. The AIs have got me. But FDL have already solved this problem of needing light and how to illuminate here PSRs, so permanently shadowed regions or craters on the moon. Nature actually published the work 2 years ago, and here we're illuminating the Faustini crater near the South Pole. This is the fabulous FDL today. The summer sprint is on right now. The US program hit max Q this week, which we call midway. These 4 challenges that you see here are led by ESA, so the UK Europe program, which has always been hosted by Oxford. Thank you, Oxford. Although we've been hybrid since COVID. And there are another 4 challenges led by NASA, which are focused on heliophysics, where we're testing Orin for the Vigil craft, which is going to hopefully improve solar storm detection that affects every satellite up there, things like thermospheric density or drag from CMEs. Let me know if you want to be involved in FDL. It's basically fast-tracking deployment of AI for space. FDL rocks, by the way. I am very, very proud of it. So the arrival of accelerated computing with GPUs and AI is very timely, because now all industries, not just the space industry, are tackling powerful dynamics and need to not only save costs, but also address sustainability. And to achieve net zero, we really do have to move to virtual prototyping. But it also gives you that capability to not only speed up, but also scale up solutions to problems previously thought impossible.
Another incredibly complex operation.
Let me switch that off.
Intralogistics. An optimal supply chain can...
So basically, this is the traveling salesman problem. If you've ever had a Domino's pizza delivered, they're using genetic algorithms within what we call QOPT or code. Commercially, it's all about VRP, so vehicle routing, but staggering cost reductions are available today. And think routing with planetary slingshots, for example. No one is looking at this yet, as far as I know. So please take the code, use it. Or the SDGs. Back in 2019, I was in Geneva with FDL and UNEP, and 68% of the indicators could not yet be measured due to lack of data. These 17 SDGs cannot fully be realized without Earth observation and satellites and sustainable AI-based solutions. But there's a ton of innovation out there. We're all familiar with the capability of self-driving cars, but here you're looking through the eyes of TreeSwift's Jetson-based LiDAR-enabled drone. TreeSwift are a UPenn startup, and this was actually 6 or 7 years ago now. They're now very well established. Their main business is mapping the timber industries, and Oxford's been involved with that over in Borneo. Please go see the work also from the students at Oxford's AIMS too. And best wishes again to FDL, who are currently developing satellite-based biomass analysis. Put them together, and it is an incredibly powerful tool. And every satellite now needs to be smart. But Orbital Sidekick, one of our Inception partners, kicked off this industry. This is their first unit sat outside the ISS, operating flawlessly for over 12 months with Jetson on board. And this is back in 2017, so that's 7 years ago. Their latest will have completed commissioning now. And what it's doing is providing persistent monitoring, and that's for multiple government contracts. They're actually running Xavier NX on board, which is the previous gen to Orin. The other thing, we've already perfected this here on Earth, and, NVIDIA and society. So go use it for Earth Gateway Moon and other networks, like the Enceladus network that Bethany spoke about yesterday. Shona brings differentiable ray tracing to channel simulation. And there's actually extensive documentation and tutorials at that link. Again, the PDF is online. This is a shot from partners Heavy AI's work, where they're using the virtual world coupled, with precise data. I believe this was with Maxar, determining antenna placement, but it's centimeter precision. And all of that data from space can simply be streamed into Earth 2 for prediction services. I don't have time now, but there is, again, a link in the PDF. And even, Fourier neural operators, I wish I could go into this further, or using diffusion to help with prediction. I think Daniel basically talked about this yesterday. But what you do need to understand with AI is this ability today to drastically lower uncertainty with what's called massive ensembles. These operators are so trivial computationally, you can run tens of thousands of them simultaneously. So this ability from AI, and it's illustrated here, the massive ensemble capability stacked together. This is actually a hurricane forecast from, I believe it was 2019, I believe. So we're testing here. But FDL is hopefully also testing it for CME prediction. So quick recap, virtual prototyping or digital twins allow you to test risk-free, relatively cost-free in an environment where you have full photorealistic rendering, but also all the goodness of 20 years of development in our physics engine. So that's, the actual physics, changing everything from gravity to aerodynamics, where you can pull in all forms of AI. And that's everything backed up, of course, by accelerated compute. But most importantly, it's synced up to the real world, to the sensors, the robotic controllers, and to us. So here's Cesium working with the US Space Force to provide an open and interoperable geotypical sim of Cape Canaveral. Humanity has barely even started to utilize this capability. So, and have those big, bold ideas and start to use this. Think military or climate defense, private-public partnership. I mean, that was the reason that they put this together, because of how much they're now working with SpaceX and others. But space comms, and all geo-referenced. Here they're using Cesium's 3D tiling service, and you can see the data provided by Maxar. But they're also here able to couple to aircraft transponders or spacecraft, but it's all unified in Omniverse to be able to test and figure things out, without the cost and the risk of going, fully real world. But if you're worried about the learning curve, just ask an LLM. We have them writing code for you in Omniverse, generating objects with Gen AI on the fly. We're going to see massive, massive growth in this area. Here, my colleagues are asking for help, and so it's to spawn 3 SUVs and a couple of sports cars with random paint. So the AI gives the step-by-step commands, or the command line, to set up the actual assets. It moves the vehicles into parking spaces. It explains how it's doing that. Then, basically it can do anything. It can change the environment to evening. You could also ask it to put in trees and bushes or people or Ingenuity. Here we're in Omniverse Isaac, and Ingenuity is being trained with reinforcement learning. And no one's really testing this yet with evolutionary algorithms yet. I showed you earlier, we dropped it into our QOpt code and won world records for logistics planning. So more of that, please. It's the only way. Bear with me. Again, it's trying to speed me up. I'm not going fast enough. But it's the only way we're going to be able to teach empathy to humanoids, emergent good community behavior. I was with Teddy and the JPL team as they were developing Ingenuity, but unfortunately we didn't have anything small enough for Ingenuity. But the Cadre team and AIMS are currently right now in Mountain View giving, they're part of a tutorial that we're giving. And this is covering Omniverse at the IEEE event. It's a busy week this week. This is RoboCasa, take it. We've combined Gen AI with chatbots, with learning, with any kind of scene reconstruction for training generally capable robots to perform everyday tasks. Mimic Gen automatically generates massive data sets for you from just a few human demonstrations, so go try it. Here's some resources for Omniverse. You can spend more time on that on the PDF. I wish I had more time, but this extension of our physical world into risk-free virtual worlds has barely been tapped yet. So I urge you all to jump in world. And finally, a word about Holoscan. This is our real-time sensor processing platform. It was developed initially for medical, so you know that it is spot on. We've actually fully switched this vital capability from hardware-defined to software-defined. So it's simplifying deployment of an AI model in a rapid, continuously streaming pipeline. So you can jump in further here for all resources. we're basically helping SETI search for ET, SETI Institute, augmenting the ATA. And what we're doing is we're accelerating the beamforming with our RTX GPUs, but also our NICs, our smart NICs, and cache. And resources, again, are on the PDF, and hopefully you all saw Vishal's talk yesterday. But Holoscan can also control data flow for our grouped teleoperation project, where we're using Vision Pro, so sensor in, actuation out, and throw an AI policy into the mix, or even better genetic algorithms, and you've got the future trained in Omniverse, Isaac. Absolute final word. AI, let's start calling it augmented intelligence. So far as perception and hearing, AI is vastly superior to us Homo sapiens. But the real magic happens when you combine them and us, which, let's face it, is why we invented AI. But there is a caveat. AI research, and therefore our progress, is happening, AI research, sorry, and progress in AI research is happening far faster than we are progressing, or the space industry is moving. So please sign up to our developer zone. Sean can help you on that. It's online, just Google it, so that we can keep you updated with the very, very rapid acceleration of AI. Or use me as a point of contact going forward. Here's my email. Again, lots more on the PDF, and I'll share it on socials too. Thank you all for listening.